Hello, 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 hello. Welcome back. So this is part two, or the second part of our mystery sender quiz problems. Okay, we're gonna solve for part two now, or the next part, or the second half, latter of the quiz. Okay. Anyways, I just grabbed some water myself, and I hope guys ready for more differential equations. So let's go to inspection. What's this inspection? Yeah, I think this is well, they said it themselves, inspection. Okay. So for inspection, in this part, problem solving, determine the general solution while following the instruction of each number. Do test if you think the equation of a certain type. So in this type, you don't know the type of the equation unless the problem gave it to you. Unless the problem gave you the type, right? So on number one, the problem basically gave you the type, inspection. Okay, so normally I agree with the problem by saying the type. I love it. Thank you so much, problem, for saying the type. So it's much easier now to solve for the problem if you know the type. If you don't know the type, you have to test for everyone. Okay, and normally inspection is the last thing I test because it's very hard to do, it's very hard to check, and basically it's not easy, or it needs a lot of experience. It's very risky. Now that we know this is inspection, we're looking for, so we have different variable. So I'm just gonna write down what we need to look. The VDU, or this is UV, right? So this will VDU plus UDV, or if we do the fraction, U over V there, so basically that's VDU minus UDV over V squared. That's dV over U. That's like UDV minus VDU over U squared. Okay. Okay, so that's what we're looking at. That's what we're trying to find, and we call that common exact differentials. Okay, that's basically the common exact differentials. Okay, and basically that's like the simplest form of exact differential. And if we're having simple equations that we can do by inspection, we can determine those type. Okay. Now that we have this equation, I guess we got the VDU U cube, right, minus V to the fifth VDU. I'm gonna just separate the VDU minus UDV U cube, right, minus UDV V to the fifth, right? Okay, so there's like positive, negative, negative, negative. It seems that there will be one fraction because the difference between this exact differential is these are both positive. When you have a product rule, those are both positive. But if you have a quotient rule, that's a positive and a negative. Positive and a negative. So we have a U cube VDU, right? So I'm looking for the negative UDV, okay, minus UDV, and they're both U cube. Okay, see the pattern. Okay, it seems easy enough, right? It's easy when someone is doing it, but if you're the one doing it, I hope you guys will, can solve it. But it's always easy when someone is doing it. When you look at other people doing, this like wisdom of life, wisdom of life. When others are doing it, that seems easy enough. But you don't know that at the back of those like easy easy actions, or you see them doing it very easily. They have practiced a lot more. They have solved a lot more equations. They have experience, right? So I have experience and it's very easy now. Well, it's not very easy, but it's just that, you know, we get the experience to notice this type of problem. So VDU UDV, then the other part is V to the fifth, right? So I'm gonna take out negative V to the fifth, and this will become VDU plus UDV is equal to the 0. Okay. Alright. This will, let's divide both sides by B to the fifth. Okay, now this is by experience. Because this is positive and negative, this needs to have V squared, right? And in order to get V squared, we need to divide that with V squared, okay? So in this case, we're gonna do V to the fifth because we have V to the fifth at the opposite side. So this will become U cubed over V cubed. Then VDU minus UDV. Right? This is V cubed, but we take out the square. So this will be a complete quotient rule. So this become a complete quotient rule. Okay? Right? Property of fraction. Right? Property of fraction. 1 over x to the fifth is equal to 1 over x cubed multiplied to 1 over x squared. And basically, that's what happened here. Okay? 1 over 9 is equal to 1 over 3 multiplied to 1 over 3. Okay? That's a property of fraction. Okay? 1 over 9 squared, or 9 to the fifth, or let's just start with simple now. My brain cannot process without a calculator. 2 to the fifth, so that's equal to 1 over 8 plus 1 over 4. No, not plus, multiply. Okay, so I know that 4 times 8 is 32, and 2 to the fifth is 32. Okay, and 1 to the 8 is 2 cubed, and 1 to the 4th is 2 squared. Okay, now that we know, I'm just sorry, I'm just like lengthening the video. Okay, so this is not part of the differential equation. I'm just like so you guys know that I'm an instructor, right? I'm an instructor upstream, right? You guys know I'm an instructor upstream. Okay, I just like, I'm an instructor upstream, and some of my students often fail to grasp the properties of fraction. I don't know why. Fraction is very hard. Me too. You know, fraction is a very hard topic in the elementary days, in the kinder days, whatever year you study about it. But yeah, fraction is kind of hard. But you know, you still have to study it, and we still have to do it, right? Anyways, I integrate these terms, right? This will become u to the 4th over v to the 4th over 4 minus uv is equal to c. Multiply both sides by b to the 4th and 4. So this will become u to the 4th minus 4. uv to the 5th is equal to c v to the 4th. This is now our general solution. Okay, that's for inspection. Okay, so in inspection, once you determine the exact differential, it's well, it's easy because the common exact differentials are easy to integrate. The problem is determining the exact differential. Okay, will you notice the u cube over b cube? Will you notice the positive and the negative? And it takes time. Okay, my hint for inspection, okay, my hint to inspection is distribute, pair. After distribute, pair the positive, the negative, and the positive, negative. Okay, so what did we do here is we basically look out for, oh, oh, there's a positive here, this negative here, negative here, negative here. So there seems to be a positive and a negative. I look for the common positive and negative. They both have u cube. The negative and negative, they both have v cube. So I was able to determine their exact differential, right? So positive, positive, negative, negative, and positive, negative with same coefficient, okay? Then trial and error, okay? Error, same differential. Okay, so this is another part of the inspection that you need to get. Okay, because this is a u over v differential, you need to have a u over v. Okay, and what we have first is u cube only. This is u cube only, right? So you need to have a pair. So if you're gonna have a fraction, if we're gonna have like a quotient or a fraction, basically a fraction, u over v, we need the variable in its differential should be u over v2. Okay, so this is u over v, this is u over v, this is uv product. Okay, so it needs to have the same variables in the same manner. Okay, same differential, and you cannot integrate that. Don't ever forcefully differentiate it. Some of my students always forcefully differentiate dx, differential of yx, integrate or differentiate. You cannot integrate that. Okay, some of the students forget the basics. Okay? Don't ever forget the basics. Okay. Anyways, let's proceed with the part 2. You know, it's turning into a preach or something, right? Ooh, solve by 2 methods. Ooh, this is a ooh, solve by 2 methods. Okay. Okay, first, solve by 2 methods. 3x plus 2y plus 7 dx plus 2x minus y dy. Okay. So first off, I'm gonna write this legibly. Yeah. Okay. So this cannot be separable because you cannot separate polynomials. This cannot be homogeneous. First of all, this is 0 degree and this is 0 degree, but this is first degree. So that cannot be homogeneous. Okay. Can this be exact? Okay, so this will become 0, this will become 2, this will become 0, this will become 2, this will become 0. Oh, it is exact. Alright, so meaning it's exact. So we can solve it by exact. That's our first method. So integral of 3x plus 2y plus 7. I'm just gonna write this down first. And integral of n dy, 2x minus y dy. Okay. Okay, so the integral of 3x is 3x squared over 2. The integral of 2y is 2yx because y is constant and we just simply add x, right? Plus 7x, okay? Plus f of y. So this is the integral of m dx. For n dy, so basically this will become 2xy because 2x is constant and we're integrating with terms of y. Minus y squared plus g of x. Okay, so notice that we have 2x only terms. This is x only terms. This is x only terms. This is y only terms, right? So g of x is 3x squared over 2 plus 7x. F of y is negative y squared. Okay. So their general solution is 2xy minus y squared plus 3x squared over 2 plus 7x is equal to c. Oh, y squared over 2. We forgot the 2. Forgot the 2. Right? Y squared, right? Y squared over 2. Okay. So, over 2. Multiply both sides by 2. So, this becomes 4xy minus y squared plus 3x squared plus 14x is equal to c. This is now our general solution. And that's one method. That's one method. So, we need to find another one. Okay? Okay, that's one method. So, one method is exact. Okay? So, let me write this down. What are the other methods? Separable. Not. 2 is linear. It cannot be linear because you have x dx and y dy. So basically, your variables are not of first degree. It's exact. It's not homogeneous. So we're gonna go now to other type, right? Inspection. And let's do it last. Okay? Non-exact. Well, it cannot be non-exact because it is already exact. Okay. Can it be Bernoullis? Okay. So Bernoulli, I don't think it can be Bernoulli. Okay. First off, Bernoulli. I'm gonna do Bernoulli last because Bernoulli requires you to have only 3 terms. We have like 5 terms here. 1, 2, 3, 4, 5. So I'm gonna do it last. So we have 8 and 9. And basically 9 is coefficient linear in 2 variables. I'm gonna write this down so you guys could I'm gonna write this down legibly. Coefficient linear in 2 variables. And basically substitution via equation. Suggestion by the equation. Okay, substitution via suggestion by the equation, coefficient linear in 2 variables. Okay, for number 2. Okay, so this is it is linear in 2 variables. Your x is first degree, your y is first degree, your x is first degree, your y is first degree. So it is linear. Plus 2y plus 7, that's basically a line. 2x minus y is equal to 0. That's basically a formula of a line. 0 is equal to y minus mx plus b. That's a formula of the line, right? Or ax plus by is plus c. That's formula of the line. Okay. So we can do type 9. Right? Let's do type 9. Right? Type 9. And by type 9, we basically find the intersection of the 2 lines. This is your m, this is your n. We find the intersection. Okay, so first off, 2x is equal to y. Okay, so y is equal to 2x, so 3x plus 2x plus 7 is equal to 0. 3x plus 4x plus 7 is equal to 0. 7x is equal to negative 7. X is equal to negative 1. And if x is negative 1, so I almost write 2. 2 negative 1, right? is equal to y is equal to negative 2. Meaning, the intersection of the line HK is negative 1, negative 2. Okay, that's the intersection of our line. We now substitute, and in coefficients linear in two variables, if you have two lines, we substitute the values. X is equal to u minus 1, y is equal to w minus 2. I tend to use w in the book. It says y is equal to v minus 2, but because v and u are very much the same, it could, when you're doing or solving a solution, your u, your v and u tends to be the same, right? Your v and u tends to be the same when you're doing a solution. I tend to use w. You can change the variables, but basically that's how you substitute it. Okay, let's write down again. This is our equation. Oh, it's weird. It's weird. Magic. Okay. So we substitute 3 u minus 1 plus 2 w minus 2 plus 7 dx is equal to du. If we differentiate that, dy is equal to dw. So dx will become du plus 2 u minus 1 minus w plus 2 dw. Okay. So this will become 3u plus 2w du plus 2u minus w dw. Okay. We have now a homogeneous equation. Okay, we have a homogeneous equation. Okay, homogeneous. Is this separable? No, it's not separable. Is this? Oh, it seems to be exact. It seems to be in. This is homogeneous. I don't want homogeneous because you already. Okay. The thing is, if we do homogeneous, we're gonna substitute one variable. U is equal to AW. There's a lot of substitution, and I don't want a lot of substitution. Okay. Is this exact? Is this exact? Right? W. So 0 plus 2. N is u. So this will become 2. They're exact. Okay. But we already solved exact, which is, it's okay. We already solved for it exact. And solving it exact, once we do it with homogeneous, you guys could do homogeneous. We can solve it for exact. How about another way? Oh, can we do it inspection? 3u du. I know that we don't want to do inspection, but if this is exact, common exact differential, 2u dw minus w dw is equal to 0. Okay. See this? See that? 3u du. I'm just gonna write the variables with the same variables already. Then I'm gonna separate 2. Then w du plus u dw. Okay. See? Okay. So this will become 3u du minus w dw plus 2 dwu equal to 0. Okay, we integrate all terms. Okay. So this will become 3u squared over 2 minus w squared over 2 plus 2wu is equal to 0. Now we substitute u minus 1. Not equal to 0, but equal to c. because we already integrate. Never forget C, right? Then we substitute back our equation, right? U is equal to x plus 1. W is equal to y plus 2. So 3x plus 1 squared over 2 minus y plus 2 squared over 2 plus 2x plus 1 w is y plus 2 is equal to c. Okay, I'm gonna multiply both sides to 2. So this will become 3x squared plus 2x plus 1 minus y squared plus 2y plus 4. Oh, not 2, but 4, right? Plus 4 polynomial, right? xy plus 2y plus, well, not 2y, but only y, plus y, alright? Then plus 2x plus 2 is equal to c. Okay, so this will become 3x squared plus 6x plus 3 minus y squared plus minus 4y minus 4y minus 4 plus 4xy plus 4y plus 8x plus 8 is equal to c. So what's left is 3x squared plus 14x, right? Plus 3 minus 4 plus 8. I don't know what's plus 7 minus y squared plus 4xy minus 4y plus 4y, that's 0. Okay, is equal to c. Okay, and let c minus 7 is equal to c, or c1 minus 7 is equal to c2. So 3x squared plus 14x minus y squared plus 4xy is equal to c. Which is, I think that's the answer to our previous question, the problem. There we go. Yeah, let's go. Inspection. Okay. So, basically, in my decision, I think because it's a exact differential, we can solve it via inspection. Now, can we do this? Okay. So here's the thing. If we do that by inspection, can we do this by inspection? Like, can we do it by inspection without going through coefficients of linear two variables? Right? I think we can. I can already see the 2y dx and 2x dy. So this will become 3x dx plus 7 dx plus 2y dx plus 2x dy minus y dy. Are you guys seeing it? Okay, let's integrate this, and this, right? This will become 3x squared over 2 plus 7x plus 2yx minus y squared over 2 is equal to c. And this is simply our exact differential before simplifying. 3x squared plus 14x plus 4yx minus y squared is equal to c. Okay, same answer. Nice. Okay. So we solve it via 3 methods: inspection, then inspection and coefficients linear in 2 variables, and exact. Okay. Okay. That's good. Okay, we solved it. How many minutes did we use there? Ooh, that took a long time. Okay, that took a long time. 30 minutes. Okay, let's solve. Let's hope that the other one is much easier or faster, right? 30 minutes. Ooh, it's already 30 minutes. We basically solved 3 types. We solved one equation 3 different ways. So I guess, although inspection is easy, right? Or faster than normal. Okay, another. Wait, the last one, y and x. The last one is y and x. This one is another equation with weird variables. Okay, who made these exams? Okay, why is this exam different variables? Why can't you just simply make it x and y, right? Okay. I'm guessing. Okay, this is basically, to throw off the students or whoever's answering, because whatever variable is, you need to solve it either way, right? So maybe, just to confuse, okay? Or basically to test or challenge our knowledge. Yes, something like that, Anyways, this is non-exact made exact, okay? How about we test for exactness? Okay. Well, obviously, because it's non-exact made exact. So remember, differentiate at the opposite variable. So this will become the differential of 8bx minus 9b with respect to dv, right? 9b squared, right? So this will become 8x minus 18b for the opposite side, and with respect to x, so this will become, wait, is this 2x? 2x, yeah, this 2x. So basically, this will become 2x squared minus 6bx, right? So this will become 4x with respect to x minus 6b, right? So it's not exact. Therefore, not exact. And to turn it to exact, if we're solving for non-exact made exact, to turn it to exact, okay, we're gonna have another lesson inside problem solving. We have two theorem. Okay. We basically minus your n with respect to y, with respect to x. And if you divide it by n, it needs to be f of x. Okay, and we find the integrating factor by e f of x dx. Okay? Okay, f of x needs to be x variables only. Okay, then if we integrate it with, if we minus the differential with m and we divide it with m, so this will become g of y. Then the integrating factor now is e g of y dy negative, and this needs to be y variables only. I hope you guys don't hear the dogs, but yeah, neighbor is here. Dogs be like bark 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 bark. Okay? So that's basically case 1. Case 1. And this is basically case 2. Okay? That's the only case. And if those two cases if f of x is not x only and f of y is not, in case 2, g of y is not y only, you cannot simply turn it to exact. Okay? Alright, let's do it. Okay, this is your... Okay, I'm just gonna put this aside. Oh, we have solved a lot. That looks so nice. That looks so nice to look. We have solved a lot, and knowing that we have solved a lot, it's always fun to check what we have learned and done. Check what you have already accomplished, right? whatever you have done in life, okay, or wherever you are, don't forget to look at what you have already, accomplished, right? Sometimes we may despair that, oh, I haven't accomplished yet. Yeah, maybe you have accomplished some little things, do some little things, take a look back, take a breather, take time to sit, meditate what you have learned, and maybe you have learned a lot, and you want to learn some more. But anyways, words of wisdom. Anyways, n of x over, let's minus first. Let's minus the 2 differential first, right? So 8x minus 18b minus 4x plus 6b. So this will become 4x minus 12v. Okay, and that will become 4x minus 3v. Okay, which is this one, right? This one. Okay, so this is n, right? So if we divide this, the difference of the 2 differential, so this is, okay, let's write it legibly. It's not 2, okay? It's not 2. Maybe some other, or maybe you guys may read it as 2m. No, it's not 2. It's mu, okay? Or partial differential. It is the partial differential of n with respect to the partial differential of y. Oh no, it's not y, it's x. Okay. So that's 4x minus 3v divided by n over 2x x minus 3. That's n, right? That's n. This is n, right? This is n. So that will become, cancel x minus 3v. That will become 4 over 2x, or 2 over x. And that is f of x. Take note, your f of x is now x only variable. It only contains x. It only contains x. Okay? Okay? For science, we're gonna try m. We're gonna try m. Okay? For science, okay? We're gonna divide it by m, right? So 4x minus 3v v 8x minus 9v. Okay? Take note, we cannot simply divide it. Okay? So it's a complex fraction, or it's a harder fraction than the other one. So if you cannot simply divide it, it's not a common multiple. If we check gy, or g, well, that's basically gv, right? Or it's not only a v variable only term. It contains x and v. It doesn't contain only v. So meaning, doesn't contain only v, meaning you cannot use the case 2 as you cannot use case 2 as a integrating factor, or you cannot use case 2. We use case 1 because it only contains x variable. 2 over x is equal to f of x, meaning integrating factor is e to the 2 over x dx e into ln x e ln x squared. Okay, cancel e ln x squared, integrating factor. Okay, that's the integrating factor. And by definition, we call the integrating factor because we multiply it to your equation. So we multiply this, right? 8v x cubed, right? We multiply this by x squared. X cubed minus 9v squared x squared dx plus 2x to the 4th minus 3v x cubed dv. Okay, and it says that this should be exact. So this will become 8x cubed minus 18 vx squared, right? For the n, for the right side, for the n, this should be like 8x cubed minus, wait, 18, right? 3 times 3, what's 3 times 3? 9. There's something wrong. Oh, wait, I forgot the 2. Right? Yes, I forgot the 2. So this should be like 6. 5. Okay, this should be exact. That's why I like stop myself. Or like we basically like stop solving. Because if we did the equation right, this should be exact. But if that's exact, then we maybe have done something wrong. So I'm backtracking and we didn't multiply 2. So that becomes 6. And 6 times 3 is 18, right? 18 vx squared. So therefore, it is now exact. And once it is exact, we simply solve for it. mdx. So 8vx to the 4th over 4 minus 9v squared x cubed over 3 plus f of y. So that's the integral of the m part. Then the n part, okay, right? X to the 4th. So that's become x to the 4th over 4. It will become 8avx to the 4th. Then this one, x cubed, or from x squared, it will become x cubed. So 9v squared x cubed over 3. So on the right part, 2x to the 4th. So that will become 2x to the 4th v. Because we're integrating by v, right? Not y, but v. Okay, we're integrating by v. We're integrating by v, so 6v x cubed, that will become v squared, right? So 6v squared x cubed over 2 plus g of x, okay? This will become 3. This will become 3. Okay, this will become 2. So basically, our general solution is now 2vx to the 4th minus 3v squared x cubed is equal to c. This is now our general solution. Okay. And that's the general solution to our non-exact equation made exact. How many hours? How many did we took a lesson? We made some lessons. How many minutes that? 12 minutes. Oh, we solved it via 12 minutes. So basically, the important thing between non-exact made exact is you know the process of making it exact. And making it exact is basically you took out the difference of the differential of m of m with respect to y and with respect to x. Where's the key? This one. Yeah, there we go. M with respect to y minus n with respect to x. Then divide it with m or m. N or m. And if it's n, it should be x variables only. If it's m, it's y variables only. And this basically your integrating factor is e raised to the f of x dx or e raised to the negative gy dy. If it's not, it cannot be turned to exact. Okay, which is the case for we divide it by m. It doesn't contain one variable only, so we cannot use m. We use n. N for nothing. M for mating or mate. Golly, mate. Anyways, I don't know what accent is that. Hey, let's solve for the last question. I hope you guys ready for the last question. You know, it's been a long video. I think it's been a long video, and I hope you guys learned a lot. Oh, it's another solve by using two methods. Can we use inspection here? Can we brute force the equation here? I don't think we can use the inspection here, right? Okay. There's 3 variables here. Look at this. V squared plus 6u over 2vu minus 2du over dv is equal to, there's two variables here. Let's divide that by -2. Okay, so this will become v squared over -4 vu plus 6u over -4 vu plus du over dv. See, there's three variables that could be linear or non-linear or Bernoullis, right? So I'm gonna try du first. This is u. Okay, let's look for the, okay, this is u, cancel u. Cancel, this will become 3/2, right? Then cancel v, right? So we're looking for the variable. Is that u? U. Oh, that's u squared, right? That's u squared. Okay, that's u squared. So this will become u only, okay? So we're looking for the first degree variable. That's the first degree variable. -3/2, right? U over v. U over v, this one. Okay, that's the first degree u. Then let's go to the opposite side. 1 over v, positive v over 4, u -1. Okay, so this is a Bernoulli equation. Okay, first degree u, first degree derivative u, non-first degree or u to the n, right? So we divide both sides by u to the n, divide by u -1 or multiply to u. That will become u du over dv minus 3/2 u squared over v is equal to v 2 over 4. Okay. Then we let z is equal to u squared. dz is equal to 2u du. dz over 2 is equal to u du. So this will become dz over 2 dv minus 3 over 2 z over v is equal to v over 4. Multiply both sides by 2. Okay, we already have solved Bernoullis equation, or we already have a video about Bernoullis equation. So if you guys want to learn about Bernoulli, I have a video. You guys could check out the playlist or the link in the description, right? We have already a Bernoulli equation video. Multiply by 2, so this will become 2, right? There we go. And now this is linear, and we use Yepex Depex. This will become z e to the integral of -3 over v dv is equal to the integral of v squared over 2 e integral of -3 over v dv dv. Okay, z is equal to a multiplied to -3 ln v is equal to the integral of v squared over 2 e -3 ln v dv. Z e ln v -3, so that's basically v -3, right? So v squared over 2 v -3 dv. And z is u squared, right? Z is u squared. We substitute it before. V -3 is equal to v squared multiplied to -3. Is that v squared? No, it's not v squared. Okay, we mistook the 2 dz over 2 as v squared. It's not v squared. Okay, I remember it's not v squared. Okay, I remember it's not v squared. Okay, so remember to always to like write your equation separately. It's not v squared. Why am I doing that? Okay. Sometimes if you solve too much, this is the last problem, right? Sometimes solving too much gets you tired, So solving is also problem solving, or basically, knowledge or thinking is an endurance game, if you find it hard to think, you know if you're finding it hard to like solve for equation, or you're easy to get tired when you're thinking, maybe you're not uh you know uh your endurance is not high enough, or you're not exposing yourself to that kind of situation most of the time. So in order to have a longer stamina for math, you need to solve more. Okay, the integral of v negative 2 is v negative 1 with respect to negative 1 multiplied to 2 plus c. So basically, this is u squared v negative 3 is equal to v negative 1 negative over negative 2 plus c. Multiply both sides by v cubed and negative 2, or just positive 2. So this will become 2u squared is equal to negative v squared plus cv cubed. Transpose it to the opposite side. U squared, 2u squared plus v squared is equal to cv cubed. Okay, this is now our differential equation, or general solution. 2u squared v cubed is equal to c. Whew. Oh, okay. I'm getting tired. It's the last equation. So that's two method. That's Bernoulli. You know what? I'm easy for a no brain, like not thinking homogeneous. This seems to be a homogeneous type. Okay? This seems to be a homogeneous. V squared plus 6u squared. Multiply both sides by 2vu dv. So this dv minus 4vu du is equal to 0. It's a homogeneous equation. So let's substitute u with xv, right? So du is equal to x dv plus v dx. Okay, let's substitute that. So v squared plus 6x squared v squared dv minus 4 v xv x dv plus v dx, okay, is equal to 0. This is the last. Okay, so we must endure. And you guys know, I guess you guys can notice that I'm less joking. I'm less joking now. I'm less joking now because probably because of the tiredness. Okay, but solving 8 problems, plus talking, it's I guess it's hard, right? Maybe if I don't talk that much, it's gonna be easy, right? But of course, this is a teaching video, teaching video. I hope you guys are learning something or knowing how to solve this type of equation. Plus, it's basically yeah, what I've been telling. It's a skill, solving problem, mathematics is a skill. Okay, it's not knowing, or it's not knowledge. Well, it's a knowledge based game, but it's a skill. Arithmetic is a skill base. You can calculate, you can sharpen your mind arithmetically by solving more. Okay, it's a skill. It's not knowledge. It's not knowing 1 plus 1 equals 2. Because if you remember, if you memorize all the mathematical or the arithmetical equation, you're gonna have a hard time because there's an infinite combination of arithmetic equation. Right? You can do 1 plus 1 equals 2 in a lot more different ways, and you cannot simply remember that. Anyways, that's all. Right? So that's become x squared v squared dv. Then negative 4 x v cubed dx is equal to 0. Okay? So negative 4 v squared x squared, 6x v squared. So that will become v squared plus 2x squared v squared dv. Right? Minus 4x v cubed dx is equal to 0. Okay, that's separable. V squared dv 1 plus 2x squared, right? Okay, minus 4x dx v cubed, okay, is equal to 0. Divide both sides by v cubed and 1 plus 2x squared. So this will become v squared dv over v cubed minus 4x dx over 1 plus 2x squared is equal to 0. Okay? Let u is equal to 1 plus 2x squared. Du is equal to 4x dx. So cancel this one. This will become dv over v minus du over u is equal to 0. Simply integrate, right? ln v minus ln u is equal to ln c. ln v is equal to ln c plus ln u. ln v is equal to O. Okay, so I'm gonna make this ln u one, okay? Because we already have u, okay? Just make sure that you remember what you substitute. Okay? ln c u1, raise both sides to e, then that will become ln v. Okay, I'm gonna double check our variables, so we might have a mistake, right? Because we already have u, so it's very weird if we substitute u again or we let u again. But in this case, I think it's very, we can backtrack, right? V is, oh, let's check any variables. There's no variables here. Okay. V is equal to c. u1 is 1 plus 2x squared. 1 plus 2x squared. And x is u over v, right? We substitute, right? X is u over b, or u is equal to xb. Then x is equal to u over v. So basically, v is equal to c 1 plus 2 u squared over v squared. Multiply both sides by v squared. So this will become v squared, v cubed is equal to c v squared plus 2u squared. Oh, it's kind of like the same of our answer to the other type. Okay, this is our answer, right? There we go. Oh, it's the same. We have almost the same. But sir, you know, it's not the same. C is at the opposite side. So we can just simply v cubed is equal to c v squared plus 2u squared. So we can just simply divide both sides by c. Then 1 over c v cubed is equal to v squared plus 2u squared. Then let 1 over c is equal to c. Then c v cubed, oh sorry, c v cubed is equal to 2u squared plus v squared. Okay, it's the same. We solved it by 2 methods and we have done it. Okay. Thank you so much for staying with me. For those who have stayed for all of this, thank you so much for staying. And I hope you guys learned something. This quiz is kind of fun. You know, we have used almost all of the type. We have used Bernoullis, coefficients, linear, and 2 variables. I hope there's like substitution in, you know, suggested by the equation. But we almost used all of the type on this equation. Inspection, homogeneous, separable, Bernoullis, non-exact made exact. Right, that's very fun. And knowing that we have learned everything, it's very fun. Alright. And yeah, see you guys later. This is our solution for this test or quiz. Hope you guys learned something, and if you guys have any question, feel free to comment it on the comment section. And guys, it will greatly help if you follow and subscribe. Okay, we're gonna have more of this, and I'm not coughing anymore. We're not having flu, so yeah, I'm gonna upload more. Thank you so much, guys. Bye bye. See you guys later. Bye bye.